Good day. I'm Bronis Desipinski. I am the chair of the OpenMP Language Committee, in addition to being the Chief Technology Officer for Livermore Computing at Lawrence Livermore National Laboratory. Today, I'll be telling you about recent happenings in the Language Committee. In particular, I'll be telling you about the newest version of the specification that we have just released. So this is hot off the presses news, and in fact, in the wonders of modern technology, it's actually anticipatory news. In addition, I'll be telling you some very, very late breaking news. It's a surprise I'll hold for near the end of the talk. As I mentioned, this is a little bit anticipatory because this is we're anticipating that it will be ratified in November 2020. I'll tell you more about the process, but I'm very confident that it will be. So OpenMP 5.1 is the latest version of the OpenMP specification. Several members of the Language Committee, including myself, published an article in the last year in the proceedings of the IEEE on the ongoing evolution of OpenMP. And in that, we laid out kind of the vision of OpenMP, as well as a nice review of its history and how we got here. So how we got to where we are and where we're going. And the basic vision is that OpenMP will broadly support on-node performant portable parallelism, which is consistent with its original goals. The goals have evolved a bit over the years, and the vision has evolved with that. But it's actually surprisingly consistent with where it started over 20 years ago. So OpenMP 5.0 fits that vision with enhanced device support and additional new models of parallelism and several other extensions. It really led towards that, and I can ensure you that 6.0 will continue fitting within that vision and help us further realize it. OpenMP 5.1, our most recent version of the specification, refines how 5.0 realizes the vision. OpenMP 5.1, as is appropriate for a minor release, does not break existing code. I won't absolutely swear to that. I will warn you that we've deprecated several things. That those things will still work in 5.1. The promise that the OpenMP Language Committee and OpenMP organization in general makes is that when we deprecate something, we will actually remove it in the next major version. And while that doesn't say anything for what the implementers will do with those no longer existing features, no longer existing keywords and symbols, it does mean that you really should stop using them. And the act of deprecating them is kind of a warning to stop using them starting now. Anyhow, so OpenMP 5.1 includes many clarifications and corrections and some significant enhancements. And I'll be detailing those in a second. If you've seen the comment drafts, TR8 released a year ago and TR9 released earlier this summer, you should have a pretty good idea of what's actually in 5.1, because everything since TR9 has just been a result of making sure that everything is in good shape, that we don't have any major errors in the specification, and that just that everything fits together appropriately. In the process of adding all of the things we've added, we didn't miss any significant interactions. It involves 251 GitHub issues, which is more than I would have expected, and maybe more than some implementers would have liked, but I'll make no apologies to them. And if you want to know why, I'm happy to speak further on that sometime. Anyway, the significant extensions that we've added include the interop construct, which is something that improves support for native devices. So it allows you to be able to interact with things like CUDA streams. The format of this construct actually supports general interoperability. So if you want to interoperate with things like thread building blocks, it will also support that. Basically, what it does is provides a opaque type that can be populated with important information about the native device support, and then you can use various calls that are added, runtime calls that are added to the specification to get that information and be able to link together the use of the native device support with typical OpenMP device support. We've also added something called the dispatch construct and improved the declare variant directive. So the dispatch construct works with declare variant. It allows you to define variants for functions that you can then add device-specific arguments to, and including things that are derived from the interop construct support. In addition, we have added further declare variant support that allows you to mark regions of code that should be compiled for specific OpenMP contexts, which will generally apply for, say, a specific kind of device, but be elided in any context that doesn't match that context. So both of these significant extensions are the subject of other talks that will be available at the OpenMP booth. The interop construct will be covered by Tom Skoglund from Lawrence Livermore National Laboratory, who's the co-chair of the Accelerator Subcommittee. And the dispatch construct and the declare variant enhancements will be covered by Ravi Narayanaswamy from Intel. And he's an important developer of their OpenMP support. So a couple more significant extensions included in OpenMP 5.1. The assume directive is a new directive that allows you to state things that the OpenMP implementation can assume for a specific dynamic context, dynamic scope. So it applies to a structured block. There's several different forms, but basically it allows you to say that some invariants will hold, and these invariants can include things such as a promise not to use some OpenMP constructs, or even larger portions of OpenMP. Like you can say that you won't have any OpenMP parallelism in that context, or that you won't use any OpenMP runtime functions. We actually expect that some implementers will define, there'll be implementation defined assumptions that you can declare that actually say that you will conform to a subset that they support and provide optimization for. This is also the subject of a deep talk available at the OpenMP booth that will be provided by Johannes Dorfort from Argonne National Laboratory. Then finally, for the significant extensions in 5.1, we have added loop transformation directives. And so these are ways to specify what we would think of as traditional sequential optimizations for loops. In OpenMP 5.1, we've added support for tiling and unrolling of loops. And so these are in the form of the tile directive and the unroll directive. and you can control how many iterations are unrolled. You can control the block sizes of the tiles. In general, this is a very important step for OpenMP. The motivation for adding these new directives is that in this way you can control how these optimizations interact with the parallelization of your loops. Previously, in fact, OpenMP directives for parallelizing loops would often cause compilers to not apply these optimizations, and whether they would be applied before or after the parallelization was done would vary. And as I said, this is also the subject of another deep dive talk available at the OpenMP booth, and this one will be presented by Michael Cruz also from Argonne National Laboratory. All right, well, so those I think are the most major extensions, but we've added many other things which I think you'll find useful. Probably the biggest next things that we've added is that we now support all versions of the base languages, C, C++, Fortran, and Fortran. So we added complete support for C11, C++11, C++14, C++17, and C++20, completed support for Fortran 2008. The C++20 support, we're kind of particularly proud of that since C++20 is also being finalized and released we expect it to be done in November, but we have several members of the OpenMP language committee who also participate in the C++ committees, and so we were able to have a good insight into what the feature set of C++20 would be, and be able to provide full support for it immediately. And in addition, we've also added initial support for Fortran 2018. There are some caveats on that support. So if you use some new features from Fortran 2018 with OpenMP, the behavior is not well defined yet. We'll be working on completing that, which has been the general strategy that we've adopted for adding support for new base languages. Another major addition in many ways to OpenMP is that you can now specify directives in C++ using an attribute syntax, using attribute specifiers. Right now, this is largely syntactic sugar. Instead of using the pragma format, you can add the directives on as attributes. This allows you to provide OpenMP directives in some context in C++ that there was no way to get at in the past. We expect that in future versions of OpenMP that we'll have capabilities that are enabled because you're using attributes that would not be possible to support through pragmas. Another significant addition is the error directive. And what this does is allows you either at compile time or at runtime to have the compiler emit a implementation defined message in addition to a message string of that you provide to the directive. And it also has the ability to either stop compilation or to cause execution to stop. The fatal behaviors are particularly useful when used with things like the meta directive, so that if you encounter them in an OpenMP context that you didn't expect, you will have the immediate effect of knowing that you need to change your code. We've also added another construct called the scope construct, which allows you, say, within a parallel region to define a scope upon which you can do things like defining reduction. So you can get the result of a reduction without ending a parallel region. Another significant enhancement is that you can now map function pointers, so you can now easily call function pointers on a device. This improves support for things like C++ classes, and then in general just makes it more easy to support common paradigms for the way people write code in C and C++. Another thing is we've defined device-specific environment variables, and so now you can control default behaviors by setting the environment in which your application starts. One that I'm proud of is we've added the nothing directive, which has an amusing name, and what it does is, well, nothing. It's useful in particular with meta directives. So you can now specify that indeed you want nothing to happen in certain contexts. So that enhances clarity. It actually allows you to specify a default of nothing, which it wasn't really clear in 5.0 if that your code would be correct if you didn't specify any directive variant. And in addition, it allows you to define no action as having a score that's higher than other actions if you have contexts which end up with the same overall score. All right, well, so we could argue that some of those enhancements are refinements to existing functionality. We've got a few others ways that we've refined existing functionality. One in particular is the mask construct. So this is a new construct in some ways. What it really is a new name for what you've known as the master construct, which has been deprecated. And the reason for that is, well, some people find the term master offensive. Whether you find it offensive or not, there's no reason that the code and that the specification needs to retain it. So now the thread that starts a parallel team is called the primary thread. If you use the mask construct with no clauses, then you will get the same functionality as you would have previously with the master construct, and thread 0 will execute the region. There'll be no device data. There'll be no data environment created for it. It's a very lightweight way to limit execution to a single thread. The mask construct adds the filter clause, which if the parameter to it matches the thread number of the thread that encounters the construct, then that thread will execute the structured block associated with the construct. And so in this way, you can actually have multiple threads execute the region, but more importantly, you can have some thread other than thread 0 execute that structured block. Another significant enhancement is that we've extended the atomic construct to support compare and swap atomics. And through the way we define the compare and swap support, you can now specify min and max atomics in C and C++. They were already available in Fortran because min and max are intrinsic functions in that base language, but they were not available operators for atomics in C and C++ previously. We've added many clauses, including things as amusing as the no wait clause to the task wait construct. That combines with the depend capability on task wait to give you the ability, some useful ability to specify synchronization between regions without causing your code to block all tasks. And we've also added the strict keyword to strict modifier to the grain size and num task clauses on task loop. We've added many other things. We've added several runtime routines. These runtime routines include ones that work with the interoperability construct support, but they also add new memory allocations, including OMP realloc. I already mentioned the deprecations of the master construct. We also had deprecated the master affinity policy. That will now be the primary affinity policy. And finally, we deprecated Cray pointers, which our survey did not find any users, OpenMP users, who actually still use. And so we've decided that the best thing to do was to deprecate that. And any mention of Cray pointers will be gone as of OpenMP 6.0. All right, so the big additional news is that we've decided that we're going to have an OpenMP 5.2. The plan is that 5.2 will be released no later than a year from now. We're hoping to get it done sooner than that, ideally by late spring or early summer of 2021. The decision to have this additional minor release came about late in the 5.1 process. The reason was because there were some things that came out of the adding of attribute specifiers that we felt could have been specified a little more cleanly if we could consolidate the syntax definitions for all of the constructs. However, we decided that that would be too significant a change to the way things are written for 5.1 without having to delay the release of 5.1. So the expectation is that in general, 5.2 will not add any new features or enhancements, but it will significantly clarify things. In particular, we expect many restrictions on the use of clauses will be consolidated with the consolidated syntax, which we also expect will probably uncover some inconsistencies, and as a result, we expect to make the specification more consistent. So there may be some small changes that emerge out of that. We also will likely reduce some other redundancies that we found, in particular in the specification of the tool interfaces, and in particular the first-party tool interface. The one thing that may involve some changes to the actual functionality in OpenMP is we will consider reducing the caveats to the Fortran 2018 support. But overall, 5.2 should be viewed as an extended quality control pass. And to give you an idea of why you should view it that way, while we already have 4 issues created for it, it will almost certainly not go beyond about 50 issues total and be nowhere near the 250 some that we have for 5.1. So finally, OpenMP 6.0 is not being delayed as a result of the decision to release 5.2, so it will still be released in 2023. We expect many significant enhancements for it. We've got many things that we've already been discussing and that we deferred from 5.1 as being too significant for a minor release. This includes things like deeper control of exactly how prescriptive specific clauses or constructs are. For example, we may provide a way to cause your execution of a parallel region to generate exactly some number of threads. We expect to have more support for memory affinity and complex memory hierarchies. We're looking at ways to support pipelining and also in event-driven parallelism. So these would be better support for essentially new parallelism models for OpenMP. With these, we would pretty well cover the full range of available parallel programming patterns. We will definitely continue to improve device support and support for heterogeneous node architectures. We are looking at extensions, for example, to the deep copy support that's provided by the declare mapper directive through allowing things like the specification of serialized and deserialized functions. One thing that as I sort of already mentioned, when we decided that we would start deprecating things in 5.0, we also made a firm commitment that the next major release would remove any deprecated features. And so the list of deprecated features in 5.1, all of those features, whether they were deprecated in 5.1 or in 5.0, will be removed in 6.0. Overall, we already have 78 issues that are being considered for 6.0. I expect that number to be very much higher by the time we are done. And with that, I am now done, and I thank you for your attention, staying with it all the way to the end.